Hi everyone, I'm Mayank, and I'll be presenting our work on multimodal humor dataset predicting laughter tracks for sitcoms. A dataset is based on a popular TV series called Big Bang Theory. The task which we propose is, given a dialogue consisting of various dialogue turns having video and textual information, the model wants to predict whether the dialogue is humorous or not. These conversations may be among more than two characters. Sitcoms, like Big Bang Theory, have the audience laughter track whenever something was found humorous by the audience. The show was recorded in front of the live audience. Thus, we can get grounded the notations for dialogues that made people laugh. So in the dataset, we have humorous label if the chunk of the dialogues is followed by a laughter track and non-humorous otherwise. Concretely, if the chunk of utterances is followed by laughter track, we label that dialogue as humorous, and if the chunk of utterances is well before the laughter track, we label that as non-humorous. This is an example of how a dataset looks like. Attributes like scene, information, participant, humor start, humor end, time, etc. are present. But for training, we only use video and textual utterances and the corresponding ground truth labels. Now some dataset stats. Current version is made from 5 seasons, having 110 episodes, from which 82 episodes were used for training, 6 for validation, and 22 for test, which amounts to around 5,000 dialogues in the train split, 363 dialogues in the validation split, and around 1,200 in the test split. Some more stats are given in this table and in the paper. This pie chart shows the distribution of utterances across speakers. For example, it depicts that Sheldon has the maximum number of utterances in the dataset. This histogram shows how many dialogues of which a speaker was part of were humorous. This plot shows average dialogue time in seconds across the dataset. These two bubble plots are showing word distribution in humorous and non-humorous dialogues. More the size of the circle, more the frequency of that word. Distributions being roughly the same, hint that classical bag of words based models will not be very successful. This is a t-SNE plot made by randomly selecting 1500 images from each humorous and non-humorous category. Now, if we replace each image by a dot, such that a green dot represents a humorous sample and a red dot represents a non-humorous sample, you'll get a plot like this. The random distribution of these points hints towards absence of any visual bias. Characteristics like these make a dataset challenging. In an attempt to solve this task, we propose a multimodal self-attention model. Textual utterances are fed to a sequential attention model, and video sequences are fed to a 3D CNN. Resultant utterance level features are attended and concatenated and are fed to a binary classifier. These are our results. We tried with various text only, video only, and baselines which were using both video and textual information. For details about these models, please refer the paper. As you can see, MSAM is the best performing model. We did an experiment to see if there is some correlation between speakers who spoke those dialogues and humor, and an experiment to see if model trained on the proposed dataset generalizes well. These are qualitative examples when a model fails. Discussion about why a model fails on these examples and what we could do to improve a model could be found in the paper. Future work may include use of other dataset attributes, use of audio information, explainability, and models which are robust to false signals due to incongruity. Thank you.